often we will solve quadratic inequalities by graphing. Now, if you look closely at this note sheet, you will see that I'm using the same graph all around because I'm interested in the inequality part and not in the actual graphic. So there will be two types of inequalities. There will be a type where you will have a y in the inequality, and an inequality where you will have a 0 in the inequality. These are two different ones and they will be solved differently, and you will be representing the solutions in different ways. Now, since this is going to be the same quadratic equation all around, let's go ahead and find the axis of symmetry and the vertex. So that will help me graph this for every single problem. So the axis of symmetry is going to be x equals negative b over 2a. And in this case, the b, as you can see, is negative 2. So if you multiply a negative by a negative 2, that would be a positive 2 over 2 times a, which is 1 in this case. So negative times a negative, that's a positive. So 2 over 2 would be a 1. So x equals 1 would be my axis of symmetry. Now the vertex in this case is going to be 1 and a y. And to find the y, you need to plug in 1 back into the equation. So y equals, if you plug in 1 for x, you will get 1 to the power 2, which is a 1, minus 2 times 1, which is a negative 2, minus 8. Now 1 minus 2 minus 8, that's a negative 9. So then my vertex is going to be 1, negative 9. So the vertex is going to be 1, negative 9, and the axis of symmetry is going to be x equals 1. Now let's go ahead and graph it in the first problem. So let's look at the first problem. Y less than or equal to x squared minus 2x minus 8. So f of x is y. Now your first step is always to graph the parabola. So what I would like you to do is to plot the points, but don't connect them just yet because we need to decide whether they're going to be connected with a solid line or a dotted line. Now to do that, let's first of all graph the parabola, and let's just plot the points. We're going to start with the vertex, which is 1, negative 9. And now since a is 1, I'm going to go up 1 over 1. And I'm going to go up 3 over 3. And then up 5 over 5. And then up 7 over 1. Up 7 over 1. So that's going to be the points for this graph. Now, step number 2 is to decide whether I need to have a solid or a dotted line. Since f of x is less than or equal, and you see how you have an equal sign under the inequality, so that's going to be a solid line. So I'm going to connect the parabola or the points using a solid line, and that's going to be my parabola. Now after I graph the parabola and decide whether it's a solid or a dotted line, my third step is to decide where to shade. So since it's y less than or equal, this is a two-dimensional graph, and I need to decide where to shade. Is it above the vertex or below the vertex? So above, inside the parabola, or outside the parabola? Since y is less than or equal, then that tells me that this is down, so I shade below the parabola. So any point below the parabola will be a solution. Let me choose a different color so you can see that. So any point below the parabola is going to be my solution. So in a problem like this, where you have y is less than or equal or y greater than or equal, you cannot really represent your solution in terms of an inequality notation or interval notation. The only thing you can say is that the solution is any point in the shaded region and on the parabola in this case, since it's a solid line. So in order to ask you questions about this, I will ask you, for example, is, let's say, 1, 5 a solution? Yes or no? So you check that 1, 5 is a point going to be inside the parabola, which is not in the shaded region, so no, it's not going to be a solution. I might ask you, for example, is 4, 0 a solution? Now, since this point is on the parabola, then yes, it is a solution. I might ask you, for example, is -4, -5 a solution? And then it's in the shaded region, as you can see, so yes, it is a solution. So to represent the solution for a problem like that, you can only say that it's all the points that are in the shaded region below the parabola and on the parabola, since it's a solid line. Okay? So every time it's f of x less than or equal, I expect to see shading in the problem. Now, what about a problem like the one below? So let me clear that. Let me move this down a little bit. Okay. So now, in order to solve a problem like this, first of all, you have to ask yourself, what are the x-intercepts? So step number one is to ask yourself, what are the x-intercepts? Now, there's multiple of ways to find the intercepts. In this case, since we're doing solving, then you look at the graph that you have, and you knew from before that -2 and 4 are going to be my two x-intercepts. So you can graph it. I'm going to just draw any graph for now. So I know that -2 and 4 are going to be my two x-intercepts. So you can use graphing to find out what your x-intercepts are. And you can put them on the number line. So -2, 4. Okay? Now, the second thing you need to decide is that do you have -2 and 4 as part of your solution? Are they included or not? Now, since you have 0, or basically not 0, but if you look at the inequality, you can see that it's less than or equal. So you have an equal under the inequality. So this is going to be a filled circle because -2 and 4 are going to be part of your solution. So a filled circle for both of them. Now, as you can see, it's the solution will be represented on the number line. Now, to know whether I need to connect them, so basically is my solution is going to be between -2 and 4? This is an option. Or is it going to be somewhere on the outside? So is it going to be from -2 to -infinity and 4 to plus infinity? So in order to decide what my solution is, I need to think about this either algebraically or graphically. Algebraically, to do that algebraically, so let's write that this is step number 3, I take a number between -2 and 4. Let's say I want to take 0, so the number 0. And I plug it back into my equation. So 0 less than or equal, if x is 0, 0 to the power 2 is just 0, so it's gone. -2 times 0 is just 0, it's gone. Then the only thing that's going to be left is -8. So I took a 0, I put it in my inequality, and I got 0 less than or equal to -8. Is that a true statement or a false statement? 0 is not less than -8. 0 is greater than -8, so that's a false statement. Then, since I took a number between -2 and 4, and it didn't work when I plugged it in my inequality, then my solution is not going to be between -2 and 4. It's going to be from 4 to infinity and from -2 to infinity. Okay? Now, for you to be extremely careful, you can double check. Take a point that's above 4, maybe a 5. Let's double check that. And plug it into your equation. So 0 less than or equal, 5 to the power 2 is 25, -2 times 5 is -10, and -8. Now that's going to give me a positive number, so 0 is less than or equal to a positive number. That is a true statement. Okay? So then it's correct. My solution is going to be somewhere above 4 and somewhere below -2. If you want, you can also take a number below -2, for example, -4. You can check it by plugging it in the equation to double check. So in this case, then my solution is going to be any number that's below -2 and any number above 5. Let me erase that. Above 4. So to write this solution, you can represent it as an inequality. Now, to represent that as an inequality, you can say that x is less than or equal to -2, and x is greater than or equal to 4. Okay? You can represent that as an interval notation, and you can do that by saying that your solution can be any number from -infinity to -2, where -2 is included. Don't forget the use, and this is two parts of a domain. And the other one's going to be from 4 to infinity. Okay, where 4 is included and infinity is just like not a number that I know of, so it's always parentheses around the infinity. So this is how you can do a problem like that. Now remember, every time I give you a problem with 0 instead of the y, it's going to be a one-dimension graph. Okay? And you represent your solution on the inequality as an inequality notation or as an interval notation. So you represent it on the number line. However, when I give you an inequality like this, then I expect to see some shading in your graph. Okay? Now let's move on to another example. So let's do number 4, or box number 4 in this case. Okay? It's going to be the same exact graph, so I'm going to plot the vertex, 1, negative 9, and I'm going to go up 1 over 1, and then up 3 over 1, and then up 5 over 1, and then up 7 over 1, and that would be my parabola. So remember, your first step is always to plot the points. How can you do that on the calculator? You can just go into y equals, go to the table, grab some pretty points from the table, and plot these points. Now, I need to decide whether I need to connect them using a dotted parabola or a solid parabola. Since it's only greater than, so then it's going to be dotted. And since it's greater than, then it has to be, I need to be shading above the vertex. Okay? So two things I need to remember. It's going to be a dotted parabola, and I need to shade above the vertex since f of x or y is greater than. So you shade up, above, okay? So I need to draw a dotted line for this parabola, and I need to shade above the vertex. In this case, above the vertex means inside the parabola. And then to represent the solution for something like this, I can say that my solution is any point in the shaded region, in this case, inside the parabola. So points on the parabola will not be part of my solution since it's a dotted line. Any point outside the parabola will not be in my solution since it's not in the shaded region. So for example, some solutions can be 1, 2, for example, can be, for example, 0, 6, anything inside the shaded region. Okay? So this is how you would show the inequality, or you would graph if you have a y in your inequality. Now, what if I have a 0? If you have a 0, then this is something that you need to represent on the number line. And the first thing you need are the x-intercepts. So I will always provide you with a graph. Yes, you don't need to shade like I'm shading over here. You can just graph the parabola and look at the x-intercepts. Or if you're allowed to use a calculator, you can put it in y equals, go to the table, and get the x-intercepts. And the x-intercepts in this case are negative 2, 4. Now, let's look at this algebraically. Now, first of all, before I take a test point, I need to decide whether I have negative 2 and 4 as part of my solution or not. Now, since it's just a greater than, it's not greater than or equal, then negative 2 is not included in my graph, so that's an open circle. And 4 is not included in my solution as well, so that's an open circle. So negative 2 and 4 are not included. And I know that because it's just greater than, it's not greater than or equal. Okay? Now, to do this algebraically, I take a point between negative 2 and 4. So let's say I want to take 0. It's always good to take 0 because it gets rid of the x for you. So let's test it. When I have a 0, so all the x will be gone. The only thing that will be left is a negative 8. Now, is 0 greater than negative 8? Yes, that's a true statement. So I took a number between negative 2 and 4 and it worked. So my solution is any number between negative 2 and 4. That would be my solution. How can I represent that as an inequality? I can say negative 2 is less than only, not less than or equal, than x, and then less than 4. That would be the inequality notation. Interval notation, you can put parentheses, negative 2, comma, 4 parentheses. Again, they are not included, that's why I have parentheses. And that's going to be the interval notation. Now, this is how you can think of it algebraically. Now, if you want to think about this graphically, let me erase all the shading part because whenever it's a 0, I don't really need to shade. Let me connect it because I'm not solving the upper part now, I'm just solving the lower part. Now, if you want to think about this graphically, now when I say that the parabola is less than 0, it means I want the part of the parabola that is below. So less than 0 means below, and the 0 in this case represents the x-axis. So I want the part of the parabola that's below the x-axis. So I'm only interested in the lower part of this parabola. I'm not interested in the upper part, so I'm going to erase all of that. And then the part that's below the x-axis starts from this point, which is -2, and there's this 4. They are not included since it's only greater than or less than, let's say. So if I want to find the domain of the red part, as you can see, the domain is from -2 to 4. So from left to right is -2 to 4. And since it's just less than, so there's no brackets, it's only parentheses. So if you want to think about it in terms of the graph, you can graph the parabola. If they say that the parabola is less than 0, it means you're interested in the part of the graph that's below the x-axis. If they say greater than 0, it means you're interested in the part of the graph that's above the x-axis, and then you can erase the extra part and find the domain of whatever graph you have, okay? So this is how you can think of this graphically. Now let's move on to another problem where we have some word problems. This one, for example. A business offer tours to San Antonio. The profit fee that the company earns for X number of tourists can be modeled by this function. How many people are needed for a profit to be at least $500? So they're telling me that the profit needs to be at least $500. It means greater than or equal to 500. So I know that's going to be -2.5 x to the power 2 plus 100x minus 300, greater than or equal 500. Now there's more than one way to solve something like this. You can choose to keep the 500 on that side, graph this in y1, graph this in y2, and then find the intersection between these two. Okay? So let's do this method. So I'm going to go to y, and I'm going to go to y1 and put the function that they gave me. So what was the function? Let me put the graph one more time in front of me. Okay, so it's -2.5. Let me make it smaller. Make this smaller a little bit so I can actually see the problem. Okay, so in y1, it's -2.5 x to the power 2 plus 100x minus 300. So that's going to be my y1. And then the y2 is going to be 500. Okay? Now, before I graph, I need to fix my window because most likely if I graph it, I'm not going to be able to see anything. There you go. There's nothing. It's still working, but oh, there's something. But I don't see the line. I don't see the whole parabola. And the reason behind that is when you go to your window, the x or y max is a 10, but I want it to be 500, above a 500. So I'm going to go to y max, and I'm going to choose a number that's higher than 500. So let's say 750. Sounds good. Now the x max has to be big too, bigger than 10, but it doesn't have to be bigger than 500. So let's choose 50 for now. So it's more like trial and error for the x max, but the y max has always to be bigger than the number that they give you. Okay? So let's graph it. There you go. I see a good parabola. Good. So the 50, the x maximum of a 50 is good. And because I put y maximum above a 500, I was able to see my line. Okay, so let's talk about this for a minute. Okay, let me talk about the graph. So they want the graph to be greater than or equal to a 500. So let's find the intersection between these two. So I need to know what this point is and what this point is. So again, this is one way to solve it. In order to find the intersection, you need to go to second trace. Write that down because I need to erase this in a minute to be able to show you the work on the calculator. Second trace, and then you go to number 5, which is intersection between the parabola and the line. And I need to find both intersections. So I need to do this twice, okay? So let's do that. Let's do second trace, number 5. I'm going to move the cursor to the first intersection. And I'm going to press enter 3 times. There you go. So my first intersection is 11.055. Write that down. 11.056. So round to the third decimal number for now. And y equals 500. We already know that, okay? Now to find the other one, I need to do second trace one more time. Number 5. And I move the cursor now to the other intersection. Okay? And let's do enter 3 times. And that will give me my second intersection, which is 28.944. So 28.944. Okay? So let me now write on the graph. So the first point was 11.056, and the other point is going to be 28.944. Now, they want the graph to be greater or equal to 500. It means they're interested in the part of the graph that is above your line. So let me choose a different color. They're interested in this part, not this one. So you can erase that one. You're interested in this part. Now, if you think about the domain of this green shape, this is between these two numbers. Then 11.056 is less than or equal to x, which is less than or equal to 28.944. And that would be my solution. So any x value that's between these two numbers would be acceptable. And again, since they said greater than or equal, it means I want the part of the graph that's above the line, and that's it, which is between these two numbers. So this is one way to do it. Another way to do it is to actually, so let me make some room so I can show you what the other way is, okay? And you can choose any method, it will give you the correct answer anyway. Now, if I have negative 2.5x to the power 2 plus 100x minus 300 greater than or equal to 500. So that means I need to move the negative 500 over. Okay? So in this case, let me just write below that. So plus 100x minus 800 is greater than or equal to 0. In this case, if it's 0 on this side, then you are basically interested in the x-intercepts. So basically the intersection of the parabola and the x-axis. Okay? So let's go ahead and go to y1, put this in y1, okay? And then we fix the window so we can see the parabola in a way that I need to be able to see the intersection between the parabola and the x-axis, since I have a 0 on this way, in this on the right side of the inequality. And then once I find the x-intercepts, I'm interested in the part of the parabola that is above the x-axis. So this is another way to look at it. It will give you the same exact value. So let's put this to the test, okay? So I'm going to go to my graph, and instead of negative 300, I'm going to put negative 800. So again, you don't have to do both methods. You can choose either one of them, okay? So let me go back to the 3. I think I'm pressing too much. Okay. So an 8 instead of the 3. And I'm going to go to y2 and clear that, okay? Because y2 has to be 0 in this case, because the right side is a 0. Now let's graph it. Let me see if I need to change anything. So I need to be able to see a parabola. That's a good parabola. But you see how it's very low, so let's fix the y max not to be that high. Let me go to window. Instead of having a y max of 750, let's put it at 500 and put negative 500 on y minimum. Like again, it's a trial and error until you are able to see a good parabola that you can use. Okay, you can keep 750, it's fine. Let me double check if that is going to look good. There you go, that's a good parabola that I can work with. Okay, now there's no intersection. We need the x-intercept, so you do second trace, and then number 2, which is the 0, which is the x-intercept. So now I need a left bound, so I go to the left of the first point. Okay, press enter. And then you need a right bound, so you go to the right of the x-intercept, the first one. You press enter, and you press enter again for guess, and there you go, it's 11.055 or 56. Isn't this the same number that we got earlier? So see, it doesn't matter what method you use, it's going to give you the same answer. Now you have to do this again for the other point so you can find the other x-intercept. So you do second trace, number 2, which is the 0, and then you need to go to give me the left bound for the second x-intercept, and in this case the left bound is going to be the left to the left of this point, so it's going to be a little bit above it. So you press enter, and then for the right bound you go a little bit below the x-intercept to the right, you see, to the right of the x-intercept, and you press enter. So you see this is the left bound and this is the right bound, and you press enter for guess, and as you can see it's 28.944, so this is exactly the number that I got earlier. Now remember that whatever graph that you had or whatever equation you had, so it was 100x minus 800, okay, greater than or equal to 0, right? Greater than or equal to 0. Greater than or equal means above 0, which is the x-axis in this case. So that's the x-axis, okay? So you're interested in the part of the graph that's above the x-axis, and you know what the two x-intercepts are. They are 11.056, let's say, and 28.944. Let me write the whole thing. So the part of the graph that's above the x-axis is going to be between those two numbers, okay? So as you can see, I got the same answer. So this is how you would do a word problem on the calculator. Now I hope the video was helpful. Make sure that you do the practice sheet and check with the answer key online.